So I'm going to really talk about the approach that LaingO'rourke bring to their projects, the business as usual approach, and it's around our internal processes that drive external abilities to use digital engineering. So LaingO'rourke as a company is a global company. We're privately owned engineering enterprise, so we have our own engineering teams. We have, in the UK particularly, have a manufacturing delivery, self-delivery model, particularly through direct for manufacturing assembly. And we have a major, or Ray O'Rourke himself has a major investment in engineering excellence, which is an innovation hub that sits within LaingO'rourke. So they challenge ourselves. So they come into our design meetings with our design consultants or our bids and actually challenge our own business to actually do something different. Digital engineering sits on top of that, and then we have a direct for manufacturing assembly approach to projects. And we also have a wide and varied portfolio of projects around the world. So Ray himself is very committed to this. He pays for engineering excellence out of his own pocket, and they deliver the value proposition back to the business. So how do we create this? It's through those specific departments and groups. So engineering excellence, digital engineering, prefabrication, modularization, where we can bring it into a project. You know, you'll see a couple of projects up there, such as Leadenhall Street in London, one of the first and biggest DFMA projects that's been carried out, and also direct delivery if we can. In Australia, it's slightly more difficult. We're actually using our subcontractors and try and partner with those guys to come up with some of these direct delivery models. Just a quick overview of some of the projects that we've carried out around the world. Through the UAE, the Atlantis, the Aldar project. I actually worked on that for a number of years whilst I was at Arup. Other industrial infrastructure projects around the world. Leadenhall building, the delivery partner for the London Olympics. So we're delivery partner at the moment for the W2B project in New South Wales for RMS. But that gives you an idea of the scale of projects that we've done, you know, Terminal 5 as well. But the common theme through this, you know, from 10 years back is all about how digital engineering will influence both the design aspects, the construction aspects, the operational handover aspects. So a number of opportunities have occurred over the last few years that have actually allowed LaingO'rourke to win some pretty amazing awards. And this isn't about saying, oh, LaingO'rourke are wonderful and look at all the great awards we've won. It's more about that all of these have a theme, that a digital engineering approach has been core to the delivery of them. So recently, the Australian Construction Achievement Award, a particularly difficult award to win, the pinnacle of construction achievement in Australia. This was won for the Moorebank Unit Relocation Project, an $800 million project that relocated the Holsworthy Army Base from one part of the Holsworthy site to a new place. So all of that was modelled up all the way through the design, all the way through the construction, component tracked, and gave a great value back to defence. More recently, the National Infrastructure Award for the Next Generation Rolling Stock Facility up in Queensland. This one, we actually worked really well with our designers. We also pushed our designers extremely hard on this to get a very high quality of coordinated model by the time construction started. But you know, the benefits of doing that there meant that there was a lot less issues coming through the construction phase. This is a project in Hong Kong. I was lucky enough to be there just before Christmas. This is the excavation or the new island line coming into Admiralty Station. So effectively, underneath the existing station box, we've excavated out 50 metres. Everything was temporarily propped. All the live running rails were actually propped on dynamic temporary works. So a train coming across every 2 minutes effectively propped 40 metres up in the air. No more than half a millimetre diversion was allowed across that dynamic track load. These things were up there for 18 months. A train didn't stop. There's no shutdowns on the MTR project, but I do have another image that this cavern, you can actually fit a Boeing 747 in. It's absolutely massive. It's again, a fantastic project. And we've also been rated as one of the most innovative construction companies by the BRW for Augmented Reality. Our SunShift solar diesel-powered solar panels, smart helmets, which we're actually going to be start trialling on a couple of transport projects recently, and 3D printing of concrete. So we're doing a lot of opportunities of where you can do large-scale 3D printing of concrete for facades, very intricate facade systems. So why do we use digital engineering? It's about surety of project outcome. It's about collaborative environment, effective communications, optimum efficiency in getting to that as-built stage, and how you manage your site safety. You know, for LaingO'rourke, site safety is the most important thing above all else. So how do you demonstrate site safety and the ability to protect your teams? We do a lot of that through the models as well. And we also sit down with our client at the very beginning, even in EOIs, we are putting a solution into our proposal and our bids that actually get our clients engaged. But we're also meeting the industry digital question. You know, the recent productivity reports are all about how does infrastructure in Australia get to that next level and using digital technology to have a better value proposition and a return on investment. So to our clients, what do we propose? 3D models, constructability reports, early planning of construction sequencing, really program visibility, logistic planning, status tracking, visualization and interface management, and visual presentations. We have a group in Hong Kong called Symmetry. That's our own visualization animation team. They're not just an animation team. They are architects, they're engineers, they actually understand construction sequencing. So all of these animations are absolutely following a construction program. They're just not animations. Within our business, design managers are massively important in making sure that during the delivery of a project, everybody understands what's going on. They're not just there running the construction delivery or the design delivery and then handing everything over to a digital engineer like a third party. We are fully integrated. Effectively, we're becoming more like digital design managers. But we all have responsibilities. We all have requirements to actually push through the design and construction phases. I won't read those out, but these are kind of the requirements that we all bring to a project through the design and design manager, project leaders, and digital engineers. I would like to see a bit of a step change in the way that projects are delivered in a collaborative manner. This is a workflow of where the model is driving everything that we need through a design and construction phase. This is effectively a traditional design consultant scope: produce a 3D model, extract your 2D drawings. I see there's a future role for the designers to start developing up the 4D model on top of the lead designer developing up the 4D model on top of their scope, do some of the 4D progress reporting, and then start coming up with some of the value engineering and method statements, which are traditionally held by the constructor. And whilst I've said here future reduced scope of the contractor, it's not really. We're actually beginning to use more and more and more of that integrated model delivery, push it more into the work breakdown structures for our work packages, push it more out into tablet-based approaches for site use, graphic status reporting. We can do our 5D outputs more efficiently, and then start looking at logistics management, QR code tracking, and then asset handover. So I'm going to go through what are the drivers. How do we get to this? So LaingO'rourke have a process called the digital engineering menu. I'm going to play this animation. Apologies for the music, it's kind of tacky. But this is how we drive all of our processes. So all of those projects that you're there, we pick and choose where we want to do what activity, but it's all driven through this menu. A lot of time and effort has been put into this across all of the phases and how it works into our other business interfaces, such as our I Know, which has our innovation portal, and how it runs through the project, how all of our design teams and all of our engineers, our trades and subcontractors are all interacting towards this. I often get asked by designers, well, exactly why do you want to use the model? You know, there's all of these things. These are the reasons that we at LaingO'rourke are using the models in the most basic format. Sequence animation, logistics planning, progress reporting are the real key ones that we want to use them for. We have 5 steps, which is our auditing of models, our auditing of our internal processes. We have to report back to the board on a monthly basis on a traffic light system of every one of our projects. Where does it sit in that progress of delivery? Where does it sit in terms of compliance to the 5 steps and the DE menu? And all of this is driven through a lot of what we do in our execution plans. We're constantly revising those. We're constantly sitting down with our designers to get the best message out there, get their feedback. How do we change our message out to them? Don mentioned these kind of things. For a contractor to absolutely implicitly understand the process of how you go from A to Z is the most important thing we need to do. Understand how a tablet-based approach works. How do we move models around? How do we verify QA, what we need to do? How do we make it work with our internal systems that are somewhat disparate and may not work? So we've come up with systems called data warehouses. They're internal developed systems. They're actually the Babel fish plug that link all of these systems together. Like everyone, we would do project startup and implementation. They're either site-based, they're team-based. Everyone is involved in a DE kickoff meeting. There's a DE kickoff meeting for the designers. There's a DE kickoff meeting for our internal team. We also get involved in the engineering kickoff. Model authoring. We don't do a lot of model authoring. We do a lot of gap filling. So this is the Mount Street project that's currently going on in North Sydney behind the LaingO'rourke office. It's about staging, it's about logistics, it's about how do you actually convey the message to your local community, local councils, businesses, how their environment will be affected by the construction project. And then you can go to the really detailed stuff. This is at the Augmented Station project, where you've got extremely complicated reinforcement arrangements that you can't explain that in a 2D drawing. So we work with our subcontractors to come up with these really highly detailed models. They're actually part of the advisory information systems. In an EOI or a bid, we start building the model from the get-go. So we use things like InfraWorks, existing context, aerial LiDAR, and we start building on top of that. So this is the intermodal facility at Holsworthy. Actually, we won this project after moving all the barracks out. We're now building on top of this as part of the Cube developments. So this was about trying to understand the amount of containers that will be in the facility, how the trains are coming in from Port Botany, and even as much as how do we actually get in all of the movable cranes. All of this was actually modelled and put into a 4D model. So when we presented to our client, we were really convinced and we understood how all of this was coming together. Using point clouds and existing conditions models overlaid, we're doing a lot of signal sighting stuff, trying to understand if we're refurbishing, upgrading, relocating systems around railway stations. How do we actually, again, put that back without having to remodel everything in lots of detail. This is the Wynyard Station 2018 upgrade project for the escalators. All of these are going to be replaced, so we had to come up with a temporary work strategy. So we've got the existing conditions model, the proposed model, the temporary works model, and the point cloud, all working together to give you a real information understanding of what the complexities around this, and then we did do a construction sequence on top of that. You've seen some of the work by Symmetry. This is, again, the NGRS facility. What you probably don't realise is these are the delivery models. These are the models that are built for documentation, that we then pass on to Symmetry. They do a little bit of gap filling, but they're very detailed. We push our designers very hard on this. This was Hyder at the time, I think it's now Arcadis, but they worked really hard on this project. And then we start doing, again, more visualization, driver training videos, understanding how track changes are going to affect the operations of trains. We're working on the Hornsby Junction project at the moment where we're putting in new point sets, trying to work out how to improve the speed of trains across those point sets. Augmented reality, we develop apps now. We have a company that we work with that give us all these apps. They're either outwardly facing advisory tools for stakeholder and community engagements, or they're internally focused tools to help our own team and our client understand where we're going with this. The level crossing project at Bayswater, we're actually doing pop-up sessions on the platforms, getting the community using these apps every other weekend for an hour. Talk to the people who are using using the station, let them understand what's going to happen. So all of this is happening on a regular basis. The Wynyard app has been massively successful for transport. You now can get SMS pushed out through this. So if there's a shutdown or a closure or a possession, just through the app itself, now you're getting all of that information coming out. There's 360 views inside of this to understand the station development. Design development, we will do design reviews on a regular basis. That moves on to understanding what a visual method statement. So when we start getting our designers on board, we start developing up things in a lot more detail, but also it's an advisory how our trades are going to start working into this. So very complicated areas, we start having these very detailed page by page visual method statements. Checking models against one another due to Solibri. This happens on a weekly basis. This is the Wickham Transport Interchange project. So putting back to transport all the changes that are occurring week to week. And then risk mitigation and occupational health and safety. We've developed up within Navisworks our own interface so we can attach a risk register, basically an Excel spreadsheet. We can then sync that back to the model. We can apply these beacons. These beacons are then have risk attached to them, red, green, yellow, depending on severity. It can be construction risk, it could be safety risk. All of this is presented every week to transport as part of the design meeting. So they're fully aware of where opportunities or where there are issues that could impinge on the delivery of their project. We're now doing that across all of our projects. 4D modelling, construction sequencing, again, business as usual. This is a major road project that we're working on, understanding spoil heaps, road closures, diversions that will be occurring, and planned versus actual staging diagrams. So this was the recent 9-day shutdown at the Bayswater grade SEPS project in Victoria. Basically every 12 hours we updated the program. The program was then given a planned versus actual, so you actually know where you were ahead and where you were behind. We then did a 360 photo of the site at that position, linked it all together so you actually have a full record over the 9 days of every 12-hour change and make sure that you're actually keeping on top of the requirements. And then very detailed staging diagrams. These were part of the pre-start. So every day or every shift, the pre-starts, the team was sat around 60, 70 people in the room. These were gone through in infinite detail, so they fully understood the role that they had to achieve over the next 12 hours. Quantification, again, business as usual. And how you, this isn't in Australia, this is in the UK. Our team in the UK are doing straight out of the model quantification to standard method of measurement. We need to get back more into this understanding of sustainability. This was the 123 Albert Street project in Brisbane. This was actually done in 2011, where we were actually using the model to produce carbon footprint analysis using a program called Life Cycle Analysis Design. I don't think it's around anymore, but it was a bit of a pilot project. And ARUP were actually engaged by LaingO'rourke to actually do this pilot project, and actually demonstrated that the building was designed for a 5-star Green Star rating, was actually a 6-star. So, you know, the tool is there. It should be used more. And then for facility and asset handover, we're just finishing up a major project in the UK called the Francis Crick Institute, a major cancer research facility. Just finishing up tagging 120,000 assets within the building. All of this is model linked to e-documents, so you can travel around the model, click anything in the model, you'll directly go to your maintenance operations manuals, your specifications. It's at everybody's fingertips. It's got all your sign-offs and your QAs all built within this. So all of that is now built within Navisworks. So we're delivering a solution to the Francis Crick Institute. The next step is, how do you do your data drops? How do you get those progressive bits of information updated? So, we're looking around those, again, in the UK, PAS 1192, and those systems. We're a little way away from that over here. So another animation that I'll show you, again, more about some of the really cool stuff that Symmetry do. And it's really a demonstration of where the models need to be developed and how we develop them further to actually become really useful in our client engagement sessions and our community engagement sessions. So everything you see here was in the 3D models that were delivered from the designers and what we uplifted ourselves. It's not in Victoria, by the way. It's a typo. So a few project overviews. We've talked a bit about MUR. It was a huge project for LaingO'rourke. At the time, the largest single defence project to be released. It was about relocating 3,000 military personnel. 250 subcontractors were on the project. 8,000 people were on site. It was just massive. And the way the model was used and developed just to help defence understand the complexities of what they were trying to do and achieve was amazing. And Defence's engagement into this, again, was a great client-contractor process. The Francis Crick Institute in the UK, again, we've talked a little bit about this, a huge project for LaingO'rourke over there, and a real demonstration of how an asset facility model can be developed. In the UK, we are lucky. We do have a group called Crown House Technologies. They are our own, again, self-delivery building services modular delivery team. So some of those modules that you saw going in during the animations were true physical elements that were being put into the Francis Crick. On our road projects, what we're trying to do, we've got a project here in New South Wales, we've got a project in South Australia, the Darlington Road project, linking GIS directly into the Navisworks model. So you're actually tracking through the geometry on one window into a GIS on the other window, totally interlinked. So as you progress along the alignment, is giving you the real life data that you actually want to. We're also doing a lot of work around dashboarding. So this is direct information coming out of geotechnical monitoring systems about settlement. How do you actually report on that? How does the weather influence parts of the alignment? How will settlement be affected if you're trying to go through different types of material? And gives you on an hour-by-hour or day-by-day basis exactly where your potential problems are occurring. Again, that's being driven through a Navisworks model. It's being driven through dashboarding. It's being driven through direct interlinks between different systems. And then parametric systems around embankment stabilization or building up. So this will tell you in a 4D sequence type of way exactly how the layers are being compressed. How are you ahead of schedule with them? Are you behind schedule with them? ACT Law Courts was on the previous video. A very, very complicated project where you've got two existing buildings and the whole transparent bit in the middle is being constructed. It's an operational building. There's a lot of risk around making sure that the current operational status of that building is maintained through the construction, even though major construction activities are happening. The way the courts are working is that you can't have the victim and the accused in any eye line between one another apart from in the court, and how you maintain all those separations around the court. So ourselves and Oricon and Lions Architects are working hard as a jurist partnership. This is the first PPP in Canberra, so we're owner-operator of this for the next 15 years after construction. But the models are very important on how we are moving forward with understanding decanting, moving groups in and out of different spaces within the building, and how we're understanding potential issues with environmental conditions such as asbestos, lead paints, any environmental system or opportunity we can exploit by showing in these graphical ways, we're trying to do. We're also working on Brisbane Airport, excuse me. So we're about 6-7 weeks into the project. Getting our designers really cracking away now. So the white bit is the extension to the international terminal, working out all the hard standings, all the markings. This is going to be progressively developed, and BAC are really coming to the party on this. They want to use it as a pilot project. We're actually getting KPIs that we're going to start working to through the design and construction phases. Our trades are coming on board based upon digital requirements. So this is going to be a great demonstration of both, civil infrastructure, buildings, and the whole kit and caboodle. Also understanding how processes work together. So on our defence projects, understanding that they want to go from a bid to operational use, and who all the stakeholders are, how they interact with one another. This was been massively useful to put in front of defence on the new projects that we've won, to really get them to understand that we know what they're looking for and how all of these separate parties have to interact, where the decision gates are, where the digital delivery will occur, what is a geometry, what is not a geometry, what is 2D. So very important to us. So in conclusion, I've gone through that pretty quickly. Digital engineering is a LaingO'rourke internal commitment. So anybody who works with us is all right, or a commitment to them too. that they will deliver to the project. We see it as a differentiator. We don't go into any project without digital engineering. We're a massively overworked team at the moment. We have something like 80 plus projects, either in bid phase or award, that we're working through with our team. It's not BIM, because I've shown you the reason it's not just BIM. There's a whole plethora of things that we use the digital model for. It's a whole project process, as you've seen on things like the Francis Crick, and what Brisbane Airport will be. It's about what starts at the beginning will happen at the end. And it's business as usual. We don't differentiate between projects we will and will not do this on. It's done on everything. It's done on a $5 million project. It's done on a $4 billion project. There's no difference between the two. And these are two of our design managers who sit in our work winning team, who we've actually got on board now as well. So that's it. It's about commitment. It's about a group of people working together. It's about how you move forward as a group. And like Don, as a contractor, we can't do it ourselves. We need everyone to be on the journey with us, from designers to subcontractors to trades, and we're all willing to help one another. We're not going to persecute or restrict someone working on a project if they're not the best BIM delivery organisation. We're willing to help. We're willing to uplift and skill along the projects. So thank you very much.
Thanks, Stuart. Brilliant presentation there. Thanks. I was just, is there any questions? We've got probably time for one or two quick ones. Up the back, if there's there's a microphone on its way, sorry.
Stuart, I'm curious as to, I see all the digital engineering and the project workflow and the design, it's seeing that flow through. How do you actually manage, say you select a range of products that you want to put into a specific project, how then do you actually follow through? Because you subcontract out to, say, a plumbing contractor or electrical contractor, and then they come on board and they start installing the products. How do you then circle back to say, okay, well, those were the products that I wanted because they're fit for purpose, they achieve everything we wanted to achieve, their quality?
We don't. In the UK, we would specify a particular product mainly because we self-deliver. So through our Crown House Technologies group, that's how it works. In Australia, it was about performance-based design around most of the components, unless there's very specialist components. And then we would sit down with our trades and our subcontractors and say, can you meet these requirements? But we don't really go back and track what was in the design versus what's in the delivery. ACT Law Courts, we've been lucky because we've actually brought our subbies in at 30% design. So they've been really influential to how we actually get the best value for money and the best design optimization. So does that answer the question?
I guess you look around Australia and you think about the aluminium panels all located on buildings which didn't meet a fire rating. Recently there was a cement sheet with asbestos found all through the Queensland project. Affinity cables, like they keep adding up where the specification was one thing and it's all designed and then constantly then you see but what's actually built doesn't meet the design. So to me I see BIM as a great way of getting the right design, but to me the loop needs to be closed, that the products need to be exactly what is required. Yeah,
I agree. I think once you've got a component and you've gone through your risk and your quality assurance and you've gone back and approved it through that and you get some kind of approval, that needs to be stamped back into the model. And how you do that is either through data drops or it's through some method of QR code tracking. I think LaingO'rourke had a similar issue on a rail project actually, where some overhead wiring catenary specifications were taken on board, but they actually began to fail. So what was delivered actually began to fail. That was a quality issue. So we need to be more involved with the suppliers, but yeah, beyond the suppliers, to actually the manufacturer who's working with the supplier to actually make sure that some of those closeouts are being achieved. And how you actually do that, I think that's a bit of a bigger discussion, whether we can get that information back into the model somehow.
There's one more down right in front.
Yeah, first off, impressive presentation there. Two questions. First off, how have you gone about adjusting your contract types between the client and the subcontractors? And then secondly, for non-BIM mandated projects, how have you gone about marketing? Are they client driven? And if so, how have you gone marketing that business case to the client?
Generally, we make no differentiation between whether it's client specified as a mandate or not. We will go into every project with digital engineering as being a differentiator and set some KPIs out and set some value propositions out, usually in our bid phase, and we will sit down and say, right, okay, if we're like for like with a competitor on price, delivery methodology, has digital engineering got an opportunity to sway the client to actually start proving to him that there is value for money, there is an opportunity to reduce RFIs, there is a more transparent approach to the delivery of their projects. Generally, that's what happened on BAC. There was no immediate mandate for BIM. It's something that's happened progressively and become more important over the last 8-9 months of bid. To be now, it is really important to them. They've suddenly begun to realise that they can start measuring productivity, safety, and all those kind of things. So for us, it's about how do we make our life within our business easier, more trackable, traceable, cost efficient. Yeah, in that case. But we are finding very few clients that once we presented to them an opportunity of digital engineering driving a solution, that is not embraced wholeheartedly. Contracts-wise, our contracts really haven't changed. The way that we work with our key designers, we have select designers. It's Woods Bagot, Rice Corbney. It will be Oricon, ACOM, Arup, GHD. Those guys come to us knowing that there is an expectation of a digital workflow. We don't go into those projects, nailing our designers down to the lowest fee. We say, if you're coming to the party to help us deliver these outcomes, there will be reward in it for you. So we're not going to say you're going to deliver your same deliverables in 2D, now in 3D, for no extra cost. There isn't a discussion around what will it take for you guys to come and help us deliver this. So that. No. So in terms of ownership and responsibility, they're all as they were with a 2D deliverable. Digital setting out from a model. We will talk to the designer and say we would like to use the model for this. There will be a discussion around the legalities of maybe that area. The same use of the model for coordination and clash detection. The lead designer is still responsible for the coordination and clash detection. The digital engineer is there to manage the interaction of trades, subcontractor models into the design. So there is no real difference.